Okay, please go ahead.
Hello everyone. Thank you for taking your time for my presentation today. My presentation is about the casting defect lossless test through computational simulation to optimize metal casting design. It sounds complicated and hard to understand. So I hope you guys have even little knowledge of the metal casting or have already heard it in terms of metal casting. Don't worry, I'm going to explain about what is metal casting and what kind of product made by metal casting and what is the casting defect. So let's get started with my presentation. So first I'm going to introduction, including guys, as I said, the definition of metal casting and the metal casting product and what kind of defect during making the metal casting. And this presentation, actually this based on my project to make optimize metal casting. So to make metal casting, I decided what is the basic modeling data. And based on the modeling data, I made the metal casting, the modeling, and then by using the computational simulation, such as it's called the Magma software. By using the Magma software, I made the research from the metal casting design, and I made the conclusion and Q&A. And the picture is showing the starting point of a metal casting. This is a furnace, and this is the liquid metal with high temperature. And so that means the molten metal. And to make a shape by using the metal, so we have to make the solid metal to the liquid metal by using the high temperature. And pouring this is the pouring cup of part of the metal casting structure. So this is more detailed casting design. This is called the flask, and this is the main shape. It's called the cavity, and this is starting point. Liquid metal will be pouring to the pouring cup and pass through the down screw and the runner come into the cavity, and after some time, the liquid metal will be solidified with the shape I want to make. So what is the metal casting is a kind of it's kind of industrial process that involves the pouring the molten metal into some type of the mold to create a certain geometrical shape. So this is a kind of the metal casting the product in piping fit, and it's a kind of the cylinder and a big automobile, and it's the representative the product of the metal casting, the automobile wheel and iron fry pan, and lots of some part of automobile's engine. Cylinder or the engine mounting. So those items around us is made by the metal casting. You guys have some understanding about the metal casting? Okay, good. This is my project description. The main purpose of the project is to detect the casting defect by using the computational simulation Magma software, and then to reduce the casting defect. So the Magma software is a very impressive tool of engineering program. It gives 3 models and result of casting process in order for the many manufacturers to make adjustment design variable to make metal casting, such as the pouring time, dimension of plastic, or even the material specification. Actually, this is the very impressive big money saver for the casting industry due to the ability to design and modify without having to spend lots of money on the failed attempts. Because without the computational simulation by the Magma program, if you made the casting product and you find some crack or some porosity, some kind of metal casting defect, so the already made product, metal casting product, will be in the trash. So to prevent it, not happen to throw away the metal casting caused by any casting defect, engineers or any manufacturers, they are using the Magma program to find the metal casting defect. So what is porosity? Yeah, this is very difficult. It's like this. This is the final metal casting product, but has some crack or porosity. So as I said, to prevent porosity and metal casting, we have to engineers need to find the porosity, which area might be occurred in metal casting, and then by using the computer program, and if they find some porosity, they need to change some design variables to reduce the porosity. So this is my 3D modeling to make the casting design. It is called the sun gear. It's like a sun. And this is my casting the design. This is as you see in the pouring cup and down screw and the runner, and throughout the pouring cup and the down screw and the runner, liquid metal come into this cavity to shape the gear sun. And by using the Magma program, I find the first simulation. According to first simulation, which has condition pouring time 2.3 seconds, very short time. And as you can see, this is a porosity, very huge. Yeah, it will be the trash, and it's very bad quality in metal casting product. So I changed the pouring time 5 seconds and 10 seconds, but there are some still huge porosity on top portion of the gear. So that means that it's not related to the pouring time changing to make metal casting. So I changed the design variable in metal casting is to move a razor here. Both sides, located both sides of the gear will be changed. Change the top side of the gear. But this is the result of the simulation 3. Still porosity of top side the gear. So, and I ran the temperature analysis by using the Magma program. And this is the razor. The function of razor is to provide the liquid metal to cavity, not to the porosity. But this picture is showing the razor's function in my project on simulation 3 is not work because the razor already solidified before the gear is solidified. That means it's not work to support to provide the liquid metal in the cavity. So I changed it. This is my final simulation to make a metal casting design, and I changed the size of razor. And then there is compared to simulation 1, 2, and 3, I got some impressive result to reduce porosity. Even though there is some porosity in the out diameter in the gear teeth. So according to the result from the simulation 1, 2, 3, and 4, I got a conclusion And this is the main conclusion. The razor, the relocation along with the biggest razor design makes even better result in porosity reduction in my project. Yeah, this is my okay. That's all I prepared for my presentation today. Thank you for your concentration, even some the way that the complicated.